Hi everyone, welcome to our webinar in participation with STMicroelectronics and Witekio. Frank, can you introduce the webinar?
Absolutely. Thanks everybody for joining today. My name is Frank Human. I'm on the business development team here at Witekio, and along with our executive solutions director, Pierre Gall, and Loic Chassot, and potentially Terry Crespo, we are very happy to welcome you to our special partner webinar with ST on embedded security and automated testing using the STM32 family microcontrollers and microprocessors. For those of you joining us for the first time, I'll make a quick introduction to Witekio. Witekio is an IoT software design and consulting firm. And we help high-tech makers and OEMs create and scale their software, especially for their embedded applications, from low-level security, chipset, board support packages, all the way up to UI, UX, and cloud design. We've been doing software consulting work for about 20 years now. We have 5 offices globally. That includes here in the US in Seattle, and then we have 2 in France, 1 in Germany, 1 in the UK. And that has totaled thousands of projects with companies like L'Oreal, Microsoft, and some of the ones that we'll show later today in this presentation. And I think it's also very worth noting here that we are authorized tech partners with STMicroelectronics. To that note, Loic, I'd like to hand it over to you for just a moment, and you can make an introduction from the ST side.
Yeah, thank you, Frank. So, okay, just an overview of our STM32 portfolio. So, STM32 family of microcontrollers and microprocessors offer many devices with high performance, real-time capabilities, digital signal processing, and low power operation and connectivity. So all these devices can be used in various applications in the industrial or consumer market. We have already been delivering billions of devices in many kind of different applications, such as factory automation or sensors, graphic HMI, motor control, digital power, IoT devices, wearables, meters, medical monitoring, and so on. So among the last STM32 series we introduced, you can select, for instance, if you need performance, you can select the STM32 MP1, which is the microprocessor based on Cortex-A7, or the STM32H7 in the microcontroller family. Would you need motor control or digital power? You can select the STM32G4. You have the STM32G0 for entry cost, STM32U5 in case you need a low power with more security, STM32WL or STM32WB supporting RF protocols such as Bluetooth, low energy, Zigbee, LoRa, wireless M-Bus. So all this portfolio is also complemented with a comprehensive ecosystem of tools, software, and solutions. So you can see on the right side of the slides the STM32 ecosystem, including STM32 Cube, and also STM, and also our partners. So our partners are also complementing all this ecosystem. On the bottom of the slide, you have what we call the solutions, including motor control or connectivity and so on. So basically, you can retrieve all this information on the STM32 web page.
Thanks, Loic. Yeah, thanks for the overview and showing us some of the different models that we have here, and we can share the slides, of course, after the presentation. We've got a very busy agenda today, so let's kick off into the subject matter here. We'll be covering leveraging some software to promote the MCU security features, running code test automation using a new tool that we call Pluma, and then the Zephyr RTOS. It's impacts that it's making in the development space today, and also how to think about some other real-time operating systems. And then we'll make some time at the end here for Q&A. From the Witekio side, we're hoping that our years of experience developing in the field will help to add some color around the STM32 family. We've done everything from simple Nucleo board bring-ups to production-ready cases. And so we hope to add a sort of boots-on-the-ground perspective with some insight from the front lines. And I suppose all that being said, let's jump into what I would consider potentially the most important topic here. And definitely the hot buzzword of today is security. We move into how to leverage the security there. First, maybe let's go into a little bit of the why of that. And Pierre, if you don't mind, potentially you could share with us some of the why and stuff that we hear from our customers on the security side.
Yeah, sure. Thanks, Frank. So let's introduce this topic, which is a hot topic about the security. We've trying to answer to why integrating security into a MCU project, MCU device-based solution. So we identify with our experience at Witekio 3 major topics that bring really the attention of, okay, you probably need to integrate security into the solution because you are maybe to be careful with this topic. So the first one is about the brand image and the brand image protection. For sure, we have some application and we have some customer doing cooking machine, coffee machine, or different type of home appliance, where in case of corruption of the devices in terms of hacking, they could have bad image, they could have media communication and around the product that could cause really degradation into the image, into the brand image. So we have to be careful. We need to do security for some time just to protect the brand, even if there is no safety or value protection risk. The other topics are more about the value and the safety. Also on the left side, you can see that we are talking about medical devices. So for example, we are doing some normative development with STM32 project, microcontroller for some of our customers. As soon as you have human life risk or a water heater, there is a risk of explosion, or in the surgical robotics, there is a really high risk for human life. You have to be careful with these cybersecurity topics to be sure that there is no risk for this for the end users. And on the right part, the last test topic is about protect the value and protect the customers. So all of you probably already heard about industrial spyware, but we already work, for example, on a door lock system openable through a BLE mobile phone. So here there is some risk for the value for the customers. And we will also talk about another example, which is a keyboard, a smart keyboard, where that could become a keylogger if it's not correctly protected. So all of this topic is really why we need to protect. Now let's focus on how at STMicroelectronics you manage this risk. And Thierry, can you say more about that?
Sure. Thank you, Pierre. Yes, in ST, the way we see security is that our customers have valuable assets and they require protections. So the very important thing is the way we see the market is that every customer has different assets and you need different protections. So in ST, we are a duty to provide you every tools that is needed for you to protect these assets. Next slide, please. So for this, we have created a security framework around the STM32 that we call STM32 Trust. So you can find the web page by just tapping in Googling the STM32 Trust page. So this is to protect the assets and to fulfill, in particular, 12 security functions. These security functions are taken from several security standards for protecting IoT device in particular, but not only. We are protecting the code of the firmware code. We are protecting a lot of different things. So we are providing secure boot. We are providing secure manufacturing. All the functions you will find to reach your own customer security assurance. And these functions are provided either by hardware IPs or by software developments, by services, or working with partners like today with Witekio. Okay. And we will reach different security assurance level. So next slide, please. So on this slide, you will see that ST is working and as a policy with ARM platform security architecture, so the ARM PSA and SESIP. So SESIP is from a global platform. So these two standards allow us to get a security assurance with different levels. So the levels are described in the slide. So the highest, of course, is providing the highest security. And we started with the PSA level 1 on the STM32 L4 and L5. We increased to level 2 with the L5 and the TFM, so the Trusted Firmware for Cortex-M. And then we moved to level 3 today for both PSA and SESIP on the STM32U5. So we reach a very good level of security, including the physical resistance. And we provide also a set of secure elements, so side secure elements, which are component chip that can help you raise the security level, for example, up to common criteria EL5+, or FIPS, or the Trusted Computing Group, or the GSMA even. So with devices like the ST-Safe, the TPM, and the ST4SIM. We also went into evaluation on PCI POS. So this is for the point of sales. And the L4 was pre-certified, and our customers today are certifying their product like the L4, the NP155, the MPU product, or the U5. They are certifying it PCI with the version 6, so which is a very high security standard for payment.
Thanks, Thierry. We see, I think, a lot of pathways here and a lot of the tools available in the STM ecosystem. Maybe let's see something in action, see how it works. Pierre, would you mind sharing a little bit of the how and who we've helped and a little bit about how it works?
Yeah, sure. So now we see that the STM32 and the family and the STMicroelectronics provide a lot of tools, a lot of recommendations about security. Let's focus maybe on two examples, two technical layers that are really key into securing devices based on microcontroller. And the first one I would like to talk about is a secure boot. And indeed, the secure firmware update that is needed for keeping the secure boot. So what is a secure boot? Just in few words, it is a capabilities for a system to trust the firmware who is loaded. So that means when you start your device, you are, as a device manufacturer, you are sure that the firmware running on your device is yours. It is based on what we call chain of trust. It is based on tools that will allow you to make this security happen. And in the case of STM32, we are used to use the X-Cube SBSFU, which means secure boot, secure firmware update, a layer that allow you to create this secure boot environment into an STM32 microcontroller. It will use different technical layer like the write protection, the reload protection, to allow this microcontroller to protect the firmware to be replaced by another one. If the firmware is replaced by a firmware not authorized, I mean not signed by the device manufacturer, the device will not be allowed to start and the device will be completely blocked. But you will not start a firmware which is not your firmware, you as a device manufacturer. So it is based on signing, verification of the signatures, private key, and all this kind of elements, and it could integrate secure element to be done properly. Another example of and another key topic in security is the secure communication. How can I open a secured communication between my devices and a cloud, between my devices and my mobile phone through a BLE communication, for example? in that way, we also have some dedicated mechanism for doing that. So mainly based on a secure element or a TPM for advanced features. And you will have to create what we call a specific device provisioning process to make a kind of, to make it simple, exchange of keys that are creating a kind of protected channel between your devices and your cloud, or your devices and your mobile phone. So all of these solutions are based on private key generation, certificate, and system of security. Let's now focus on where we see that, and we can give you some example of products that we're working on, where security is key. So the first one on the left side is a keyboard based on a STM32 objective of this keyboard is to propose a smart keyboard where everything in terms of layout can be changed easily, integrating a kind of an e-ink screen behind the translucid keys. So you can easily have a very high customized keyboard. The main issue for the customer about the security was we have a firmware, we have a microcontroller running code into this keyboard. I don't want this keyboard become a keyloader. We need to make a protection for the firmware of the protection. That's why we implement a secure boot system and a secure firmware update through USB and also through BLE. So we implement all of that based on the STM32 Trust framework. The second example is a sport equipment manufacturer, which also working on a STM32 microcontroller. We integrate in this project TPM for advanced security features, and the objective was to create a secured channel with the cloud, but also with a mobile. So we implement different layers, different way of creating this channel, but all of them was based on what I explained just before, security, private key, certificates. The last one, I can't give you so much detail, but it's an IoT end-to-end security solution where we need to implement a little bit different than a pure secure boot, because we need to implement a measure boot solution. So what measure boot is, in few words, is just a way to not block the device when a firmware which is not allowed is loaded on the device, but being able to communicate with a cloud or communicate with an external dependencies, indicating that this particular device have been compromised. So it uses some specific TPM features to integrate messages into the cloud communication. But the main objective of this customer was to correctly handle the security. So just few words to finish on this topic. Today, having security and implementation of security onto an MCU project base is a must-have, and it's something that we have to be done as soon as you are in a way in a communication in a connected world. The boot process and the system update is a really risky layer, and as soon as you need a security integration, a secure element or a TPM is really a masterpiece for this security enablement.
Thanks, Pierre. Is this just a quick question? Is this something that most of our customers that we work with, is this something they come upfront knowing about their project, like, hey, we're absolutely going to need to, go through this, or is this something that we need to tease out a little bit? We'll walk them through an attack tree, something like, or I mean, yeah, I guess that's my question. Is this something that most people know about right now, or is there still some awareness gap?
To be honest, 5 or 10 years ago, nobody cares about the security. Now, more and more, we see some scope of work, some customer requests coming with security, specific security requests, but that's not yet 100% of the case. Maybe, I don't know, 60% of our scope of work we get from customer integrate security. So there is always a part of enablement, of explanation, of acculturation we need to do for customer, and more particularly for the one who is doing a connected system with a remote update and so on. So
Great, thank you very much. Yeah, I'm also curious to learn at some point about if there's limitations to secure boot and on and on. Moving the needle here just a little bit, we can shift gears toward the test automation. What it is. I wanted to go ahead and drop a comment here that if you all have questions from the audience, please feel free to drop them into the questions box over on your right. We have some time set toward the end where we can field those for you if there's anything about the booting, secure booting. And just wanted to say thanks again to you, Pierre and Terry, for going through that component. Looking forward toward the test automation, I suppose the best part of this would say, what is test automation? Why are customers doing test automation? Is it some sort of savings, et cetera? And Pierre, if you wouldn't mind, taking the lead on this one, and then we can switch for Loic if that works for you.
Yeah, sure. So just a few words. What we're talking when we are talking about test automation, we are talking a way to execute some tests fully automatically by a system, by a software, by an environment which do it without any human intervention. Why doing this kind of test? There is a lot of topic, but the first one, and one where a lot of customers are really thinking about, is the time to market. When you are doing non-regression testing, when you are very short bug discovery, when you are able to, in the night just before the development of a feature, testing it and validate it if everything is working, you clearly understand that you will be able to fix any bug discover very quickly. If you are waiting for weeks or months to discover an issue, because it takes time to do it, because you don't have the test guys available for doing the test immediately, you can understand that fixing this bug that have been done months or a few months ago could become complex and take more time. The second topic is about the potential human error. We all know that doing everything manually could cause some issue. We all we already heard that in our customer office that ask if the developers have correctly tested the feature, and they said, yeah, I've already tested it, but not this one because I'm pretty sure it is working, but that's, you are more or less pretty sure that bugs will occur in this area. So making it automatically make your test really high quality, really reliable. You will have a really way to reproduce this test again and again, and it's really become really mandatory as soon as you would like to do some performance or reliability testing with very long cycle of reboot, for example, of the devices, or very long cycle of testing a specific feature. The last one is about protecting your budget. It is more or less linked to reducing your time to market. It will avoid extension in your development roadmap, saying, okay, we need to fix that, and you will be late and you have extra development needed. But it could also avoid some product recalls. And we have an example of customers that needs to recall thousands of devices to reprogram it because there is no way, there was an issue in the remote OTA, remote update support, that they need to call back all the product and make a long campaign of programming of these devices. So with automated testing, they could have a chance to discover this issue earlier and not having this stuff to do. So maybe Loic, you at STMicroelectronics, I know that quality is a key topic for you. Can you say more about that?
Yeah, so indeed, at ST, quality remains a key priority while developing software. So taking as example our STM32 Cube software suite. So just a quick introduction before. So STM32 Cube is a combination of software tools and embedded software libraries. So if you use STM32 Cube, you can develop in STM32 Cube IDE or in your preferred IDE, such as Kyle or IAR. So STM32 Cube is a full set of PC software tools. So to address each step of the development cycle, so with configuration, development, programming, monitoring. And it also embeds, on the right side of the slide, software bricks to enable advanced functionalities in STM32 devices. So with this offer, we took care to offer a business-friendly solution with no copyleft license terms. So developer benefit really from a free and open source software solution. And all this is available at no cost for developers and can be openly shared and redistributed, provided it is used on STM32 devices. Okay, so this is what we call STM32 Cube. And okay, indeed, for this STM32 Cube suite, quality is a priority. So we are also using automatic testing for sure to test all these software suite, and we perform systematic verification at all stages of the development cycles with documentation reviews, static analysis versus coding standards, code reviews, code coverage, tests, and so on. So really, the objective is to enable STM32 developers to focus on their differentiators. So they can rely on this STM32 Cube software, including drivers and also RTOS and middleware, and they can really focus on their application. So if we look at the main aspects of the STM32 Cube quality assurance, so first of all, reliability, ease of use and efficient usage of STM32 products are the main drivers. So efficient usage of STM32 products means that we ensure that the hardware features are really leveraged by the software drivers. Then second, we also gather many feedbacks from STM32 developers through various channels, such as ST Online support or GitHub or the ST community also, and from STFIs also. And okay, from this we analyze defects and we rapidly fix critical ones, and we also take the opportunity to apply some continuous improvements. So basically, that's the quality assurance for STM32 Cube.
Thanks, Lok. It's good to understand from the ST ecosystem, how they can help from a quality standpoint. And sort of piggybacking off of that notion, we're talking about continuous improvement and the quality assurance here, focusing on maybe implementation of this and the costs associated with the testing and continuous improvement. Pierre, are there best practices that we can share that would help in development here?
Yeah, sure. So why doing automatic testing? We explained before, and we were talking about cost and time to market. Here is just a rough graphic explaining the global cost of testing. So on the horizontal axis, you have the time of the project, so development and delivery, and then go in a maintenance period. And on the vertical axis, you have the cumulative cost of your tests. So for sure, at the very beginning of a project, it's very easy. It costs less to just do manual testing because you have less features, you have less activity to perform in terms of testing. But with the time, when you add new features, when you have to run regression testing regularly, more and more, it becomes interesting to use automated testing solution. Because when you will be at a delivery point, you will have your full automated testing test available for running, and it will cost very few euros to run it because it will be done automatically. We at Witekio really trust this way of working and doing quality. So that's why we develop an internal framework, which is called Pluma. that have been developed for now years at Witekio, and becomes today a product that we are able to propose to our customers for doing their automated testing. So what is interesting in using our tools is just you have a framework ready to go instead of recreating or using your own stuff and have to set up everything at the beginning of the project. So let's focus on our vision of the automated testing and how it works. So here is just a global overview of how Pluma, but it's a general overview of how automated testing works. On the first part, you have how can I trigger the beginning of my automated testing, and more particularly, how can I do that in the continuation of my automatic building, of my continuous integration. So we are able, with Pluma, to treat directly the starting of the test suite from GitLab or Jenkins, which is a continuous integration test. You can also do that manually using a command line. But the first objective of this tool is to deploy the latest binaries built from your continuous integration directly to your target. So we are able, through ST-Link GTag or through an FS update for Linux, to update the target to update your target, your devices, using the latest binaries. Then when your target is ready to go with the latest firmware, you are ready to launch a set of tests that have been described in high-level languages. So we at Witekio use a YAML file, which is a way of describing tests, to have a high language that allow you to say, okay, I would like to first deploy a file, then run this command, then extract this information, then check this regular expression to validate if the output of my application is what I expect. So it can run a large set of tests, controlling some, for example, power supply to make some power cycle on a microcontroller or on microprocessor-based devices. You can interact with your device through, I don't know, BLE or a serial bus or every type of I/O you can imagine with to interact with your platform. Or you can go through a really advanced scenario, like, for example, asking for a microcontroller to grab the latest temperatures and synchronize it with the cloud, and then ask Pluma to get the latest version of this value directly on the cloud, on the web platform, and validate that all the chain, all the communication is working well. At the end, all these tests have to be reported correctly. We are today supporting two different ways of reporting, the standard and classical Excel file, which could be useful for most of the use case, but we are also able to integrate the test result directly into a test management app. So we natively support X-Ray, which is well integrated into Jira, and which is really well when you would like to perform a high level of coverage. So, for example, you have all your requirements in Jira, all your test case in X-Ray, and all your results automatically added to X-Ray. So that means more or less every days or every weeks, you will have the complete test suite executed on your platform with the latest binaries built from your continuous integration, automatically reported into your test management app, giving you some information about the global quality of the project.
Go ahead. I was just saying, it sounds like from my end, like, key takeaways are you're saving costs associated with project extensions, or any issues that you may run into. You also would be avoiding mistakes up front and maybe time to market or deployability. I'm assuming this becomes even more relevant now with the chip shortage. That things could have some sort of code portability. Where they're at. I see. This next slide obviously says pro tips. Would you, if I'm someone in the audience and I'm beginning to think about how to approach a test automation, what are ways that I can actually do that, or if I wanted to engage with something like that?
Let's focus on the standard test pyramids that maybe all of you may know. Let's start with the functional test. So for the functional test, if you want to perform automation, you need to identify the most important test case, because perform automatic testing on functional test could be more complex because need highest complexity of interaction with the system, but that's not impossible. So identify the most important functional test case and automate it. Then the integration test is where the automation is the easiest to perform, and this is where you have to maximize this automation. All the developers can be clearly stakeholders in implementing some of this automated test case. The QA team can also implement this test case, and at this level, you will be able to perform test easily because the features is limited at a specific features, and it will be easiest for an automated tools to handle that. At the very low level, we are talking about unit testing. So for that, you don't really need what we call an automated testing tools, but you can directly use frameworks, unit testing frameworks. We are used to use CMOCA, GMOC for doing such unit testing. And in that case, this unit test will run directly into your continuous integration and will not really use an automated framework. So if you want to know more about our way of testing with our tools, which is named Pluma, don't hesitate to go to the website, and don't hesitate to contact us to get more information. You're on mute, Frank.
Hey, thank you. I appreciate that, Pierre. So yeah, I was just mentioning we do have some questions coming in on the chat here on the side. Feel free to ask questions. This is on, obviously on the automated testing or on the securities, and even in the RTOS, which let's move into here so we can make sure we have enough time to field all these questions at the end. What is Zephyr is my question. Why do we see it as a future leader in the RTOS world? And maybe for some context, it would actually be helpful to go back and look at, okay, what is an RTOS? Why are we running that versus some sort of bare metal application? And then, what are the advantages that Zephyr may hold? Pierre, would you mind sharing just a little bit about like what is an RTOS on an MCU, even to if I'm beginning to approach that?
Yeah, sure. So we'll not go through a pure definition of what is an RTOS. It is an operating system which is supporting real-time features, and you probably all of you already know some of them, and we will go deeper into this RTOS family after that. But just as an introduction, why using this kind of RTOS? I think there is a lot of interesting argument on enabling an RTOS on the system, and we always have a lot of customers doing pure bare metal development on RTOS. So just let's try to identify why we think at Witekio that using this RTOS is a good way. So first one is about the multitasking and the efficiency. So yeah, when you are doing tasks, you are able to break a complex problem into smaller pieces, smaller problems. So it could be easier to design, easier to manage, and you will have a really efficient way to manage it, and you will be able to optimize the usage of your MCU because the operating system will be there for that. The second topic is about abstraction layer and portability, and in more general, we are talking about platforming. The way, the basic definition of platforming, but the way to correctly implement your architecture, I mean software architectures, to be able to reuse this core layer into a range of products. We are doing that for a customer which are doing a coffee machine. So the very first machine, we implement a complex architectures to be able to support multiple machines. But at the end, we are now at 13 versions of this machine, and every new version is really do efficiently. So having an operating system will allow you to have a really high level of portability, and will allow you to change your microcontroller without many complexity in this current shortage world. That's a key topic, to be able to change easily the microcontroller you are using. The last topic I would like to address today is about service and structures, and using an operating system will give you some guideline for designing your solution. You will have dedicated layer with a middleware, an application layer, driver layer. It will be easier to build, easier to test, and with the right operating system, it will be really easy to integrate communication layer and correctly structure everything. So maybe we can go, Loic, in a quick overview of this RTOS world with some example of operating system running on STM32.
Yes. So many RTOS solutions are available for microcontrollers. I have listed few of them on this slide. So most of them are now open source. Some are redistributed by ST, for instance, in STM32 Cube. So if we consider FreeRTOS or Azure RTOS, so they are part of STM32 Cube solution. Some others are supported by ST partners and are also available as STM32 Cube expansions. So for instance, Emboss from Seger or Unison from Robots. Other ST partners are also proposing other RTOS like Microdigital, Western Embedded, or ARMKyle, RT-Thread. So again, this list is not exhaustive. And STM32 is also well covered in Zephyr RTOS. And I guess Pierre Witekio can help our customers to develop STM32 application based on Zephyr.
Yeah, sure. You're right. We are doing Zephyr integration for our customers, and we really see Zephyr as a really interesting RTOS for the future. There is a lot of really interesting topic about Zephyr. Like, for example, it is maintained by the Linux Foundation, which is not newcomers in the embedded world. It is supported by major tech companies. You have a really interesting way of managing release and vulnerabilities, like for the Linux kernel. It also includes a lot of connectivity stacks, which means you don't need to grab a stack, an external stack, and try to integrate. It is already everything pre-packages with the operating system, and it supports a lot of hardware. I know that at STMicroelectronics, you are part of this mainline community to support the STM32 family within the Zephyr operating system, right?
Yeah, so ST works with the Zephyr community, in fact, to enable STM32 device and drivers. So it's really we really leverage also the community work. So ST is a maintainer on STM32 code base, so defining software architectures and developing core system, reviewing also the community contribution in terms of quality and also consistency across the STM32 family, following up issues, testing non-regression, supporting community also on various communication channels. So the community is very important for us. So indeed, more than 90% of the drivers and boards are contributed by the community. And this community is also contributing for reviews, testing, and driver maintenance. So ST is also ensuring an efficient usage of STM32. So in the same way we are doing in STM32 Cube. So still we want to be sure that the STM32 hardware features are well leveraged by the software. And most STM32 drivers in Zephyr are based on STM32 Cube, HRL or LL. So that's yes, that's the way we are working together with the community in order to really enable the STM32 in Zephyr.
So if I'm understanding correctly, you have ST contributors, developers that are actually actively contributing to this Linux project with Zephyr, right?
Yeah, that's right.
Okay, cool. Pierre, moving forward here, is there anything that we've been hearing that may provide some helpful context to those considering an RTOS or Zephyr, maybe some examples that we'd be able to share from one of our customers?
Yeah, sure. So just a small feedback on Zephyr. So we at Witekio are pretty confident that Zephyr will become a really important operating system in the MCU world in the coming months, coming world. We already see some industrial project using Zephyr with this connectivity stacks which are already integrated. There is a really high added value of using Zephyr, and the support of the Linux Foundation make everything easy to trust, because you have a big company behind not a big company, a big community, behind Zephyr. So just to finish our today webinar, a small example of a customer we are managing today. This is a project which is ongoing based on STM32 so integrating the natively the BLE stack. We integrate Zephyr. We are moving to a connected device, so through BLE to a mobile, but also through GSM to the cloud. We will so that apply all the best practice we are talking about in the advanced security chapter we talk today, and we will also for sure perform automated testing to be able to guarantee high quality for the project. So Zephyr is a key topic, a key operating system in the futures, and now we've seen industrial project using it.
Thanks, Pierre. So we have a few minutes left here, and so I suppose let's get to our questions here, and then we'll also give a quick slide at the end here on how to proceed if you are looking for any sort of support with anything that we've discussed today in terms of security or RTOS or anything like that. Witekio has a team of about 150 engineers that help with that. The ST gents are also here to answer the questions that we've got. Kicking this off, I think maybe the easiest way would be, because we have one that's still here within the Zephyr conversation. So while we're in this part of the conversation, Paul asked if there will be an ST wiki for the Zephyr RTOS. I don't know if you guys know if there is one coming down the line.
Okay, I can answer this one. So I don't know any plan to make a ST wiki right now for Zephyr RTOS. But yes, this is indeed something we could do, as we are developing a wiki for STM32 microcontrollers and microprocessors also. So this is one way to share some guidelines and experience on STM32 and software. Okay, so I understand that this would be useful for you. So this is something, yes, we can.
Thanks, and just for helpful reference, if I'm there, do you know of any places that people can go for information right now if they're looking for running Zephyr on ST?
I guess we don't have any other locations under the Zephyr directory itself. So,
but
there is a lot of information directly integrated into the Zephyr website. You can see the list of supported board and how it works and how to integrate it. But for sure, we can have an open discussion on how we can support you into this integration if you want to go with Zephyr on STM32 MCU.
Thanks. And so we have another question here from Benoit. And Benoit says, could you please elaborate on what ST might offer in regards to software IP protection as a part of the STM32 trust?
Yes, I can take this one if you want. So first of all, we have a lot of different STM32. So from very old to new generations. So the firmware protection mechanisms have been improved a lot from the origin of the STM32 up to the new one. For example, the one you will basically to protect your like that we call keys, the reader protection unauthorized access. We have features like the write protection, which is also used in safety. We have features, for example, to hide the boot mechanisms in order that you do a secure boot, and after, when you jump into the application code, the application cannot access to the boot. So you ensure a secure boot, and you prevent that even if somebody has access to the application and can modify something, they will not be able to boot in their botnet. They will only start in your application, and then you can ensure that your application is verified for integrity, and this will prevent the attack to succeed. So I would invite you to check at the STM32 Trust webpage, in which you will see by product what are the protection and what are the feature for protecting the IP, your IP. After, we have also devices with Trust Zone. So Trust Zone has been developed by ARM and ST in the tentatively to protect the IP and to separate two worlds: one world for the application in itself, and one world for the secure, so trusted world. So and that in that way you can manage also somehow the IP protection.
Thanks, Thierry. And I suppose focusing right around the secure boot still, Sammy asked, and this may be chip specific, but Sammy asked if does the STM32 F43X support secure boot?
Yes, we have developed a package, an X-Cube package, which is called X-Cube SBSFU. So this is for secure boot, secure firmware update, which is an example running on all different product families, almost all of them. Again, check on the STM32 Trust webpage, and you will find the link for this X-Cube SBSFU. And on the front page, you will see which devices are supported or not. The F4 is supported, and this SBSFU is an example that we provide securing the boot. After, and this is where we are working with Witekio, because Witekio can help you in understanding what is a SBSFU and implementing your own protection according to your application requirement.
Yeah. I confirm we already do that on the STM32 F4 family, so no issue. And yeah, as you said, it's a specific software IP that is if just a basic explanation, but you flash a kind of a very first level bootloader, which is protected, right protected, that becomes your first root of trust, and you integrate here a kind of first level of certificate or signature verification to be allowed to load the second level bootloader, and then the firmware that will be loaded by the second level bootloader, which is trusted by the very first level bootloader. So don't hesitate if you have any question on that topic and want to enable that on this kind of microcontroller. We can support them. We can support you with pleasure.
Mm-hmm.
Yeah, and we'll have a slide here on how to connect here in just a minute. And I suppose I see one more question here coming in from Sammy as well, and this is: can you briefly compare free RTOS, Azure RTOS, and Zephyr RTOS? Anybody want to field that one?
Yeah, that's a pretty complex question to answer in a minute, but just free RTOS is for sure probably the most common operating system we are finding on a microcontroller. There is a huge community, a huge support for many drivers, many microcontroller, and a lot of features enabled already into the operating system, but also into the ecosystem of software available around FreeRTOS. It has been recently a strong partnership with Amazon, so you also have an Amazon FreeRTOS version which already integrates all the Amazon AWS IoT stacks to be able to communicate with the Amazon cloud. Azure RTOS is in fact ThreadX. If you know this operating system, it has been acquired by Microsoft a few years ago, and Microsoft renoms Redix Azure RTOS. It's a very interesting operating system because it comes also with NetX for all the Ethernet networking communication. It also integrates GUIX for all the graphical stuff. So you have integrated frameworks. It becomes open source. At least it becomes free to use if you are managing your device management with Azure RTOS, with the Azure cloud. And for Zephyr, we already talked about that's the newcomers for sure. Less background in the but really interesting features like the embedded stack and communication stack, and also huge community and the Linux Foundation that is just behind and pushing hard on Zephyr. So yeah, I don't know if some of you would like to add some extra information, but that's just a basic comparison. We can take time to talk about that more in detail if you want.
Certainly. And I know we have just a couple minutes here, so hoping to wrap up briefly. I know, Paul, you had asked a specific question about some of the security options. I think this is the first one that came across on the STM P157 MCU. I'm hoping that some of this has been answered. Guys, is there anything that you would like to add specifically to that point here before we close?
Yeah, maybe very briefly. So on that device, the MPU device, you have two cores. So you have the Cortex A7 and the Cortex M4. So on the Cortex A7, you have a trust zone with the same capability that I explained for the IP protection, with the isolation of two worlds, so the secure and the non-secure. Then we have all the encryption, decryption, authentication devices on both cores. So you have a crypto accelerators, AES and PK. You have an hash engine, so for signature and so on. You have a random generator. You have secure boot, unique IDs, so everything is on board. And what's important to understand is that also you have the anti-tampering capability that is managed, so to detect the different attacks. And therefore, we provide secure real-time clock, with active tamper, verification of the temperature, voltage, a 32 kilohertz sensor for the monitoring, with the capability to have two cores, so one A7 and one M4, which are isolated. So in terms of software, this is managed via the TFA, so which is a trusted firmware for Cortex A, which is an open source TFM to manage the trust zone TE, trusted execution environment. And you have the OPTI, which is also a TE that is provided in open source for you to manage your Linux applications. Besides this, we also provide a lot of things, which I can briefly explain. Around the secure manufacturing, for example, that's very important. So we have tools to generate and to generate your keys and insert them into the device with a signature tools, for example, for the boot. And this is done at development and production. And you can do this provisioning with also some authentication mechanisms. That's a very short summary because explaining security on an MP157 is something difficult. I know we had only 1 minute.
Yeah, and if you guys have any more questions, we can jump to the next slide. There's a brief overview of how to proceed. There's contact information here. There's some links on our website for some of the products that we've done specifically around the STM32s. And if you have some questions, feel free to contact us. Often what we'll do is we'll have a qualification discussion, teasing out the specifics, maybe some things that you want, in these questions if you're looking at security options for specific chips. And then if maybe there is not a fully fleshed out design plan, what we can regularly do is do a systems workshop. And so what we'll do is a short-term engagement where we can help to scope out the project, clarify things that you need, lean on us and our team as expertise, where we'll be able to answer some of your questions and guide through, some things that one may be missing, lead to libraries, etc. And then we also will do development work. We'll do some augmentation of projects or take on entire pieces of projects for you if you want. That always happy to have a discussion. So feel free to reach out here. And just wanted to say thanks. I know we've run 1 minute over, but sincerely appreciate everybody's time this morning. Follow up with us here via email. We'll send out the recording of this after the webinar is completed. And I wanted to say sincere thanks to Pierre, Loic, Thierry, and everyone in the audience for asking the questions.
Thanks, Frank. Thanks to the ST team. And thanks for following this.
Thank you, everybody. Thanks for attending us.
Yeah. Thank you.
Bye.
Bye.
Thank you. Bye,
Bye.
Joel. Bye.